Good morning, Americans and humans. This is your favorite alien here on the morning of Saturday, April 8th, 2023. Well, Holy Week's almost over. We're getting tomorrow is Easter, and then you go egg hunting. Yeah. And you forget what Easter is all about. Yeah, don't forget you got Passover too for you Jewish guys. Yo. Well, today's commentary is on extraterrestrials and the human search for another Earth-like planet. Well, to give you a hint, Americans and humans. My adopted planet, because my ancestors blew my ancestral planet up. My ancestral planet used to be a little bigger than Earth. And used to lie around 4,000 light years away. You can still see there's an object there where my solar system was. But they used so much antimatter that it kind of blew up the solar system too. Ain't that trouble? You guys got nuclear weapons, and imagine what you could do with antimatter, huh? Oh, dangerous. Whoopee! That was my ancestors. Nothing like killing yourself, huh? Well, like I told you, my home planet, it took us a while to, as you call it, in your terms, terraform it. About two of your centuries. Get it back to normal. It was so polluted, it wasn't even funny. But anyway, it's good now. It is in a star about 3,000 light years away. It's about a similar orbit to the sun, to your sun. Our star is about, your sun, but it doesn't have the bad items that your star, the Sol, has here. I mean, you got a bad G-type star, as you call it. Bad, dangerous for your type of beings, and for us. But anyway, our planet rotates once every 23 and a quarter of your hours. That's a fast rotation of a day. Its year, unfortunately, is a little longer than yours because our orbit's a little longer. 378 of your days is one of our years. Yeah, okay. And if you guys want to know about exoplanets and you're looking at, you got NASA and all the rest of the guys giving you information on the internet on Alpha Centauri and other planet systems. Notice they don't tell you much about Tau Ceti, huh? Really? Don't know why. Tau Ceti. Or the star system that's 90 light years away from you. They should tell you about them. Those are two interesting star systems. Now, Alpha Centauri is a good system. It's unique. You don't see that very often. And you guys are close to one. Usually you got to go a long way to find one of those systems. It just happens that that's your closest system to you. And like they tell you, Proxima Centauri is 4.22 light years away. Okay. But put it out in your layman's terms here, humans and Americans. Let's use the American base system of a mile. Okay. And your old Einstein system. Light travels at 186,282 miles a second around there. Therefore, it's about 5.9 trillion miles that light travels in a year. 5.9. So let's round it up to about 6 trillion, okay? Make it easier. 6 trillion miles a year is what you go in the light. So you start today On April 8th, 2024, you travel around 6 trillion miles away from the Earth, so you're not even close to Proxima Centauri yet, because you still got 18 trillion miles to go. So you got another 3 years to go. A little more than that, because it's 4.222. But remember, light travels at 5.9 something trillion miles, so we rounded it off to 6 trillion. So it'll take you about 4 years to travel that. And put it this way, if you travel at our slow speeds, let's say my ship has 2 types of engines, what you would call in Star Trek impulse and warp drive. Our warp drive engines can go from 100 billion miles an hour to 3.5 trillion miles an hour. We hardly ever get up to the 3 trillion miles. Sometimes we do in emergencies and stuff like that, because, it takes a heavy toll on your engines. But if we take, say, a leisurely stroll to get from Earth to Proxima Centauri at 400 trillion miles an hour, so you take the calculations, 400 trillion, 10 of your hours, 400 billion, 10 of your hours you traveled 4 trillion miles. Another 10 hours you traveled 8 trillion miles. And then you get 4 more hours, so that's 1.6, so 9.6 trillion miles in a day. Okay, so 2 days, you're looking at 19.2, and about 3.5 days, and you're at Proxima Centauri at 400 billion miles an hour. And that's leisurely stroll. We travel around 7 or 8. So we can get there pretty fast. Hey, we could travel at 1.5 trillion and get there in less than a day. Yeah, but we don't do that. When we travel from our planet to yours, it takes us about 5 days to get here. And that's 3,000 light years away, people. Yahoo! 3,000 light years. Only 5 of your days. Kind of fast, huh? Want to go home? Yeah. Well, see, our home is, you kind of would like it. We're a little smaller. Our planet's a little smaller than yours. It's about 0.98 your mass and 0.912 of your gravity. Our sun is similar to yours, but it's a little smaller, about 0.97 of Sol. It's a little more luminous, 0.105. So it's a little brighter. And we're, about maybe 107 million miles away in your calculations from the star anyway. So, we make it good there. We got 2 moons. One's a little bigger than yours. It's about 2,970, something like that. And the other one is 865 miles. But the one that's 270 to 1,700 or something like that. That one is about 367,000 miles. It's got an atmosphere to it on there, so it's pretty good. It's got a nitrogen-oxygen atmosphere, so it's a good moon. The other one is about 165,000 miles up, and we use that for we used to mine it for a while, a couple centuries ago. We don't do much in there. It's just a stopover and people research visitor center there, where they can see. Oh yeah, you can see our planet from here. You can see the other moon. The other moon is got all kinds of stuff in there. We use it as a changeover from our planet to other systems in the Federation. Planets. We got a planet that's about a couple light years away, 6 light years or so, and so between 20 light years, we cover our Federation. But here on Earth, and what you got to realize is Proxima Centauri, like I said, you can get there at our 400 billion miles an hour. You could get there in about 3.5 days. And you'll find that Proxima Centauri, it's like I say, it's a nice little red dwarf. And the planet that you're looking at, Proxima Centauri b, yeah. And you say, oh, it's locked, but it's got one other problem. It doesn't rotate. So it's locked and doesn't rotate. And that's a problem with a planet when it's stuck like that, because you have a terminator that's forever there. So the only place you're going to find life on that planet is at the equatorial terminators, about 200-300 miles away from the terminator on the light side. Because the atmosphere can get very messy in the terminators between the very hot and very cold side of the planet. And weather is very unpredictable, so you're going to need domes in order to live on that planet. Yeah. Okay. And then you get the other 2 stars of Alpha Centauri, Alpha A and Alpha B, which are both G-class stars, just like your sun or Sol is here. So you're going to have to get over there. And mind you, you got a problem here, because remember, Proxima Centauri is 4.22 around there light years, and Alpha Centauri A, the bigger of the two, is 4.37. So if you look at that and you say, oh, okay, and then you got to take the 6 trillion miles as a light year, okay? So you take that, half a light year is 3 trillion miles. And that's 0.5. So look at the 0.5. Forget about the half a trillion for a second, but look at what I'm saying. A year, light year, 1 is 6 trillion miles. And like I said, the distance between Proxima Centauri and Alpha Centauri A is, one is 4.22 light years away from the sun. The other one is 4.37. So you got about a 0.15. Okay. So here's I'm telling you what that 0.15 is. A light year is 6 trillion miles. Half a light year is 0.5. And that's 3 trillion. A quarter of a light year is 1.5 trillion miles, or 0.25. Okay? An eighth would be half of the 1.5 trillion, or 775 billion miles. So the distance is approximately 775 billion miles between Proxima Centauri and Alpha Centauri A. Wow. And you say, oh, that's short. Well, it is. But imagine that your furthest spacecraft that you have sent out of here, Voyager 1, has only traveled 24 billion miles in 46 years. You get my point, Americans and humans? 24 billion in 46 years, yet the distance between Alpha Centauri A and Proxima is 775 billion miles. So if you launch from Proxima Centauri B, Voyager 1, It's not even anywhere close to Alpha Centauri A 46 years later. See what I mean? This is the status of your so-called technology. And then Alpha Centauri A is a little bigger than Earth. I mean, than your sun. It's than Sol. It's 1.05, I think they say it is, and 1.1 luminosity, if I'm not mistaken. Don't quote me on that, but I think that's what your scientists say it is. I've only been there once on the way here. Okay. And by the way, Proxima Centauri A has a 4 solar system, 4 planet. 3 of them are in their Goldilocks zone between the orbits of Venus and Mars. Okay, so they're about the same as your Earth. They get about the same there. They're Earth size. One is 1.1. One is 0.7 the size of Earth, and the other one is 9, about the size of our planet, close to it, about 0.9 of the Earth. There, they got moons. One's got 3, one's got 2, and one's got 4. Your Earth is kind of unique. You only got 1. And it's a kind of a strange moon when you look at it. Yeah, our moon doesn't look like that. No. Now, Alpha Centauri B is a little closer to Alpha Centauri A. So can you imagine if you had one of those planets on Alpha Centauri A, and you get Alpha Centauri B, which is a little smaller. It's like 87% the Earth size and 0.9 of the Earth luminosity, of the Sun's luminosity, pardon me, here. But it's also about maybe 500 billion miles between Alpha Centauri A and Alpha Centauri B, or Alamon, as you call it here. Yeah, can you imagine if you live on those planets? It's still 600 billion miles or so away, but the other star, Alpha Centauri B, if you lived on one of those planets, an Alpha Centauri A, would look like the Sun looks from Pluto, but a little bit smaller, because Pluto is only 3 billion miles away. So that's, you're looking at almost 200 times that distance. So it could look like maybe Alpha Centauri looks to Earth. So, but it's interesting. It only took us a few hours to go from Alpha Centauri A to Alpha Centauri B. B's got 4 planets of its own. But the reason you can't find them here, astronomers, is because, remember, you got 2 luminous stars next to each other, less than a light year from each other. Wow, that is kind of and remember, a light year is 6 trillion miles. And it's even less than a half a light year, which is 3 trillion miles. You're looking at 600 billion miles between the 2 of them. So you're looking at 6 trillion, 1 light year, half a light year, 3 trillion miles, a quarter of a light year, 1.5, an eighth, 8.75. So you're looking less than an eighth of a light year between the 2 stars. Oh, ain't that fun? So you see, Americans, here's the problem that you got. And by the way, they got some civilizations there. They're not as far as yours. When I came in 2064, when I went there, the 2 planets on Alpha Centauri B, one civilization was what we call level 2, which is approximately your Roman Empire, so around, say, Octavian's time there. And the other one was a level 7, which is approximately 1850 of your time period here. Alpha Centauri A's got 2 of the planets that have civilizations, and those are humanoids. The other ones on the other planets are not humanoids. There are arboreals, and one of them is a reptilian race. But on Alpha Centauri A, yeah, you got one that's a humanoid race, and it's in the 1950s, and that was as of 2066. So 1950 style there, So, hey. So today it would probably be a little less than that because you're only in the 2020s. So it'd probably be closer to the early 1900s today. So it's about a century behind you, basically. Uh, but technology-wise, anyway, I mean, they were just inventing their television when I went by them. 1948, 1950, where it was becoming big there. So today, in the 2020s, I would imagine that they would be in the Marconi age over there, if they go by your Earth standard of development. But you see, Americans, this is what you're having. And the other question is, if you decide to go to those planets and see if you can share some space, instead of blowing them up as you always do, you don't even have a society. Oh, and they were ahead of you in society, by the way, because they had pigmentations. One had 8. The closest one, the 1950s technology that we wanted there, had 8 pigmentations. You only got 4 here, and you can't even get yourself together. They had started to outlaw religion because they found that was getting you problems. They had outlawed politics about a decade earlier of your time. So you see, something that you have not done yet, they are starting to do over there. So hey, to them, hey, that's my type of people. You, extinction. This is your favorite alien. Good day.